Hello and welcome back for another presentation, this one on an introduction to clouds. So this is a pretty short presentation, mostly because this is designed specifically for my physical geography lecture course. So this was for like a weather and climate course. It'd be a lot more extensive talking about the different types of precipitation and stuff like that. But this is really just to introduce the top 10 types of clouds that we identify and classify. How do we do that and what do they look like? So we'll start off with the first photo I've got on my cover. This is a photo that I took. These are a very unique cloud. These are called mammatus clouds. We use that word a lot in earth sciences. Mammary, meaning breast. That's essentially, it's this mammillary shape, this rounded shape. And in this case, these mammatus clouds are actually pockets of water in a sense. They're very common in Europe, not so much in the US, but they actually retain enough water in each pocket that when it does downpour in the UK, that it can actually crush a car. So it's a tremendous amount of water. They're very dangerous, but they're very, very odd and exciting to see. This was a photo in the Alabama hills and along the eastern Sierra on a field trip. So let's talk about clouds. So this is your classic diagram of clouds showing the different types, but I really want to spend some time talking about the way that we classify them. Clouds are classified off of two features. One being the altitude in which they're found, so how high or how low. So altitude is the first, and the second is going to be the shape. What does it look like? So we're really classifying clouds off of observations. And then from that observation, we can interpret, the location, what it is. So I can look at a cloud, and based on its shape, I should be able to then identify its altitude, and then to be able to identify the name. So we'll talk about all of these clouds in a moment. But the first thing I want to talk about before we get into clouds is how does this move up? Like, how do we have this air that's able to lift up? So I'm not an artist, so don't make fun of my diagram here, but it's the best that I could come up with. So how does air move up, and why is that important? Well, because when it comes down to it, clouds are made out of moisture that are within a parcel of air. So when the air itself is lifted up, we know that the temperature is decreasing. And as the temperature decreases, it allows the cloud to condense in a sense and to create a more visible cloud versus just being gas that's trapped in the parcel of air. So by having this uplift, we're able to really identify clouds. So the first type of way that air moves up is convective. I think of convection like an oven. So it's, in this case, it's heated from the Earth's surface, that hot air rises, and as it's rising, it actually pushes that air up. And then that cold air sinks, it gets warmed up, and comes back up. We see this type of cell very often in the earth sciences. We see it when looking at plate tectonics and the way that magma works underneath the Earth's surface, and we also can see it here. Convergence is just like if you think about two cars crashing into each other. So you have two parcels of air that are pushing together, and when it pushes together, it can't go down, so it goes up. So it actually forcibly pushes air up. Another one is a frontal, and there's different types of fronts that we'll cover later when we talk more about atmosphere. But this is just showing that you have a cold front moving forward, and it's forcing that warm air up. So then it'll eventually cool down. But it's when you have this forced push of two different air parcels of different temperatures. And then the last one is orographic, which is essentially you have air moving towards a mountain on one side, the winds push it upward. As it gets pushed upward, the cloud begins to condense, it's able to rain a little bit, add that moisture on one side. So this is more, it's very much like convergence in a sense, that the air is moving, but then it hits a blockade or a solid block of rock, and that cloud kind of gets pushed up. We see this a lot, like as an example, more relative to where we are. I think of this as like the Santa Monica side, and this is the Sepulveda Pass, and then on the other side over here would be like the valley, where it's a lot drier because that air is coming off of the ocean. It's getting pushed upward. It condenses. It rains. It becomes fog often along the Sepulveda Pass, and then that moisture is kind of wrung out like in. I think of clouds like much like a sponge, that it's able to retain water, but as you wring out some of that water then gets rain on one side, then it becomes drier as that cloud moves along, and so that's kind of the gist of that. So we have convective, which is here. We have convergence error, frontal, and then orographic. So that being said, something that will be of very great help when studying the 10 clouds is this diagram. I provided it in the modules, but I mean, how easy is it to draw this? You just literally draw a big box and then put smaller boxes. What's important about this diagram is that we can see that we've now been able to create a set of boxes, one that is low clouds, middle clouds, and then high clouds. So again, this is that, remember I said clouds are classified off of two things, one being altitude. Well, here is our division of altitude. And then the last one is its shape. And so here is our columns being shapes. These are going to be puffy clouds. These are going to be clouds that are layered. And these are going to be the unique clouds, and then this is a very special cloud. So what words do we use? Well, here are the 4 root words that we use to identify clouds. The first one is cirrus. Cirrus means locks of curly hair, so it looks very wispy. So these are cirrus clouds. Another word we use is cumulus. Cumulus, when I think of cumulus, I think of cottage cheese because it needs to be, it's piles or heap, so it looks chunky, puffy. Stratus clouds means layered like a blanket. Stratus clouds are really hard to see because we're usually below the layer, so the blanket is above us, so it's hard for us to identify that it's a layered cloud unless you're able to kind of get up into it to see the different layers. But usually when we see a nice big sheet of cloud like this that looks like a blanket, we can assume that it's a stratus cloud. And then nimbus is a word that we use for clouds that bear rain. So that being said, all of these clouds here, they don't carry precipitation. Nimbus clouds will. So now we can obviously use this word and start mixing these words up to say, well, this is a very particular type of cloud. Maybe it's a stratus cloud that is also able to bear rain. So then we could call it, a nimbostratus. But we'll talk more about that in a moment. Something else that I want to mention while we're looking at these 4 diagrams, and I know they're small, but we'll look more at bigger photos in a moment. We've already, again, established clouds, altitude, and shape. Well, when thinking about the shape, something else that kind of has to be in the back of your mind is that we know that clouds are made out of water droplets. It's made out of moisture, right? So we have to decide whether it's made out of ice crystals or legit water droplets that will turn into rain. And that's something that we'll continue to talk about in these next couple slides. But just kind of put in perspective, when you see very wispy clouds like this that are cirrus, we're going to assume that these are ice crystals. These are not traditional water droplets. It's not condensed enough. But when we see stuff more like this, where it's darker, then we know that there's more water droplets. There's been more condensation that's occurred. We've mentioned this before in different presentations, but maybe you've had a really cold drink and you've been able to see the water droplets on the outside of that cup. That water that's on the outside of your cup is not from inside. It's from the surrounding parcel of air. So the contents in the cup are colder than the surrounding air, so it causes condensation to occur by pulling that water from the air parcel and sticking to that cup and then dripping down the sides. Well, that's what happens here, is that sometimes we can have a situation, like in down here, when you have a lot of moisture in the air, and because the temperatures are different enough that that dew point occurs, that we can then create condensation. Then the water becomes too heavy to be held within the cloud, in which then it drops. Fun fact, since we're talking about rain real quick, most of us assume, because we've been trained and learned that raindrops look like teardrops. They don't. Think about it. So you have a raindrop that maybe is a teardrop at the beginning, but as it's falling through the sky and going through all of that altitude, the air is pushing back on it. So actually raindrops create, it does have a little tail on the top, but as it comes down, it gets flat bottom and sometimes can be kind of pushed in like a contact lens, because as that droplet is dropping, the air is pushing back on it, so it can actually kind of make an indent in the raindrop. And then in some cases, if there's enough friction, that air will actually cut through the raindrop and split it into 2. So maybe you've been in situations where it's rained and you've seen huge raindrops. It feels like someone's throwing water balloons at your car versus very small raindrops. That's going to be the reason why. All right, so kind of moving back to this diagram, let's talk about some of these clouds. Now, I'm not telling you what goes where. I'm hoping that through the presentation you're going to be able to fill in that box, because you should be able to do this. You should be able to do this for an exam. So let's look at high-level clouds and we'll work our way down. So these are your top 3 high-level clouds, which are found between 20 and 40,000 feet in altitude. The first one is cirrus. wispy ice crystals. Wispy is not like a real word, I guess, huh? Ice crystals. So, cirrus comes back to the root that it's like angel hair. So it's ice crystals, very wispy, very clear that it's cirrus. Cirrostratus, which means that there's enough of it that it's made a layer, is the type that would usually create some form of halo effect that we would see. So again, really, really, really high up in altitude. Here it's created more of a layer system. Perfect, perfect. Then we get into cirrocumulus. So we have very light ice crystal wispy clouds, but we also see that they're in very, very, very small puffs. So we can see that here. So you see how we're using these words. So here we have just traditional cirrus. Then we tack on the stratus, meaning that it's a layer of them. And then we can tack on cumulus to mean that we have these bunch of these very, very light, wispy puffs, very thin puffs. So these are high-level clouds. So you have cirrus, cirrostratus, and cirrocumulus. Let's look at some middle-level clouds. These are from 6,500 to 20,000 feet. So here we have altostratus. So droplets of water, but not thick enough to actually rain or create precipitation, but it will be thick enough to cover the sun or the moon. Alto being tall, stratus is layered. Nimbostratus, a rain cloud that is nearly uniform like a sheet. So nimbo meaning rain bearing, stratus meaning a layer. And here we have altocumulus. So here we have tall, but we have very well-defined puffs. See how much more well-defined they are than when we looked at the cirrocumulus? Because they're lower to us. All right, so altostratus, nimbostratus, altocumulus. So here we have our low-level clouds. So this is from literally the ground to 6,500 feet. We can have stratocumulus, which means that these are massive blobs. So we have strato, meaning that you have a layer of it's very thick, and cumulus being like cottage cheese. So imagine a real thick layer of puffy cottage cheese. Here we have traditional stratus, which is just like almost a thick layer of fog in that sense, but it's higher up. And then we have cumulus, traditional cumulus. These are really large heaps, big heaps. When I think of cumulus, these are those clouds that you used to, when you were a kid, you laid on the grass during recess, and you'd be like, oh, that cloud looks like, an elephant riding a bicycle. These are your cumulus clouds. So those were 9 clouds. I know it's going to make you sick. Go back. Cirrus, cirrostratus, cirrocumulus. We've got altostratus, nimbostratus, altocumulus, stratocumulus, stratus, and then cumulus. Perfect. So let's look at the cloud 10. This is a vertically developed cloud. This is a cumulonimbus, excuse me. I call it the party cloud. The cumulonimbus is the party cloud because it can reach up to 10 miles in height. It has thunderstorms, lightning, can even create tornadoes. It looks like a big anvil head, so it kind of goes up and then billows up at the top. So these are very, very intense, severe weather storm clouds. They're very common when you have extreme weather. What's interesting is that there's a form of this that's actually produced by fires. It's called a pyrocumulus, which is where you have a large fire burning over something that had some water, maybe a small pond or a lot of really rich vegetation, and that water immediately turns into a vapor and can create this big cloud system. But I call it the party cloud because it's got everything invited and it's very, very dangerous. So those are your 10 clouds that fit in your diagram. So let's look at a slide of rare clouds. Are there more than what I've shown you, these 10? Yeah, the 10 are the main ones that we use to classify. But as we can see, there's lots of other unique variations and mixes between these clouds. I'm asking you for my classes to be responsible for those 10. These I put in here because I thought they were just interesting. So you have nacreous clouds, ice crystals, very wispy, but you can see that there's refraction occurring, so you have this rainbow effect. Mammatus clouds, noctilucent, where they're actually glowing. You have altocumulus castellanus, which is essentially clouds that are being split between layers, so you have this pulling apart occur. Lenticular clouds, looks like the Starship Enterprise. I've seen a lot of these on field trips when you're dealing with a very large mountain range where the cloud is being pushed up orographically. So it's kind of getting squished this way, but it's also being pushed down this way. So it kind of creates this layer effect. What's interesting about clouds, actually, I'll say that in a moment. And then the last is Cirrus Kelvin Helmholtz. This reminds me of like some Snoopy cartoon. Essentially, you have a cloud that's moving along. You have a large, maybe a hill or some form of feature. The air hits that, goes up, and pokes a hole through the cloud and creates these unique shapes. So again, just kind of interesting. I thought maybe you've seen one. I'd love to hear if you have. I guess I've seen this and I've seen this. I have not seen these other ones. What's interesting about clouds, before we kind of move on, is that they're they're constantly falling. So you have to imagine that because of gravity, things are always moving down towards the Earth's surface. So it's weird to think that a cloud is actually falling. It's slowly moving. So it's moving across, your horizon, but it's also dropping. And what's interesting about that process is as it's dropping, the clouds will change. So it's not uncommon for you to go from, here we go back to an earlier slide, cirrocumulus clouds to it's slowly turning into full-on cumulus because that moisture and that air parcel will continue to drop unless you have some form of uplift. And that uplift will push it back up and will kind of refresh itself. Kind of interesting, right? So I'm going to go back to this diagram, your top 10. So what you should be able to do is you should be able to pick where each one goes. So I'm going to give you a moment to have you kind of figure it out, and we'll see if you're right, okay? Okay, so that's long enough. So let's see what you've done. So here we have a drawing and a name from each one. So were you right? So as you can see, our exceptions are going to be ones that are unique. CI is cirrus, NS is nimbostratus, this is SC, so it's stratocumulus, right? Because you have a layer of cumulus. Just a layer is stratus. Cumulonimbus, the party cloud, on top of cloud 9. Cirrocumulus. So are you able to kind of push these apart? Can you see which one is which? So make sure you have this down. This will be very important for you to study your types of clouds. All right, I'm going to go back here. Quick presentation. I appreciate your time. I hope you enjoyed it as much as I have. If you've seen any of these clouds, let me know. Don't forget to subscribe to the channel so you can get access to all of the videos, and we'll talk soon.